Your vehicle weighs thousands of pounds, but its only connection to the road is a few square inches of rubber. From the outside, that small patch usually looks perfectly fine, but as that rubber wears away, the physics of driving turn against you. Less tread reduces traction, increases stopping distance, and reduces emergency control. To prevent this, manufacturers hide a small built-in safety marker deep inside the dark grooves of the tire, a feature most drivers completely ignore. This is the tread wear indicator. It is a precise, raised bar molded directly into the rubber, sitting exactly 1.6 millimeters, or 2/32 of an inch high. Monitoring this physical boundary provides the baseline data needed to prevent a loss of control during a sudden swerve or hard stop. To locate the indicator, scan the outer sidewall for markings like TWI, a small triangle, or an arrow. Marks map a path from the sidewall into the tread groove, locating the raised wear bar. If the rubber towers above this indicator, it's safe. As rubber wears down, the gap disappears. When tread becomes flush with the bar, the tire must be replaced. Checking this depth allows you to calculate exactly how much physical grip remains to channel water away before hydroplaning becomes inevitable. Checking only one groove can be misleading. A tire often wears unevenly, meaning you need to inspect the inner, center, and outer edges of the tread individually. Specific wear patterns act as symptoms. Accelerated wear strictly in the tire center suggests incorrect pressure forces the rubber to bulge. Alternatively, severe wear isolated to one outer edge, creating a heavy slant, points to a failing suspension or serious alignment issue. While the classic penny test provides a quick visual estimate, using a dedicated tread depth gauge provides the precise measurements required for an accurate safety assessment. Uneven wear transforms the tire into a diagnostic tool, warning of systemic vehicle failures that must be fixed before you install a new set of rubber. Identifying these mechanical red flags is the first step toward a broader culture of risk assessment and proactive safety. For those looking to master these standards, HSE INDEX provides a comprehensive library of health, safety, and environment guidelines, ranging from individual maintenance to industrial protocols. You can build a more proactive safety mindset by subscribing to HSE INDEX via the link in the description. Even if your tread depth looks acceptable, a tire is not automatically safe to drive on. Rubber degrades over time. Exposure to extreme heat, direct sunlight, and poor storage conditions weakens the internal structure, aging the tire regardless of how many miles it has traveled. Manually inspect the entire tire wall for secondary physical damage. Look specifically for embedded objects, dry rot cracking, or structural bulges like the one shown here. Inspect your tires regularly. Do not wait until the rubber is completely bald or until your braking distance has already become dangerous. Early checks ensure your vehicle maintains the necessary grip to stop effectively during high-stress emergency scenarios. Properly monitoring this small margin of rubber is the only way to maintain physical control over a multi-ton machine at speed. Maintaining that physical limit protects the driver, the passengers, and everyone else sharing the road.